Good evening students. Now I am teaching CBSE syllabus grade 10 first chapter real numbers. Last video I am explaining the topics of real number chapters. What are the topics? Euclid division lemma, fundamental theorem of arithmetic, decimals, next proof of root 2, root 3, root 5 are irrational numbers. Now I am explaining the examples and exercise in the chapter. Here a number when divided by 73 gives 34 as a quotient and 23 as remainder. Find the number. Okay, how we can find the number? By using Euclid division lemma. So what is the Euclid division lemma? A is equal B into Q plus R. Okay, so A is the dividend, B is the divisor, Q is the quotient, R is the remainder. So here, what is the divisor here? 73. 34 is a quotient, remainder is 23. So here, by using Euclid division lemma, A is equal B into Q plus R. A is the dividend, B is the divisor, Q is the quotient, R is the remainder. So the condition of remainder is it is greater than or equal to 0 and less than the divisor. Okay, so here divisor is 73, quotient is 34, remainder is 23. Here 73 into 34 here. So 4 3 is 12, 4 7 is 28 plus 1 29, 3 3 is 9, 3 7 is 21. So 2 1 8 4 2. So 2 4 8 2 plus 23. Here we can adding 23, that is 5 0 5 2. So here what is the number? 2505. So this number is divided by 73. Quotient is 34. Remainder is 23. Yes. Using Euclid division lemma, find H.c.f the numbers 867 and 255. H.c.f means highest common factor. How we can find? By using division method, we can find the H.c.f of these two numbers. So division method means how we can find the division method? Same. Here the biggest number is 867, smallest number is 255. So 255 3 jar, that is 15. Yeah, 15 plus 6 7. So that is 201. Again the remainder is become divisor, the divisor is become dividend. Until the remainder we can get 0. At where we can get the remainder 0, the divisor is called GCD or H.c.f. GCD means greatest common divisor. So here 255, 1 not 2 2 jar, that is 2 not 4, 2 2 jar 4, 2 0 0, 2 1 jar 2, that is here 151. Here the remainder is 51. This 51 is become divisor, that is 1 not 2. Okay, the divisor is become dividend. So 51 2 jar, 2 1 jar 2, 2 5 jar 10. The remainder is 0. Where we can get the 0? At the divisor 51. This 51 is called H.c.f or GC. So here by using Euclid division lemma, by using Euclid division lemma, we can write as A is equal B into Q plus R. So the remainder condition is 0 less than or equal or less than B. Okay, here how many times you can use the Euclid division lemma? 1, 2, 3. So here what is the dividend? 867. Divisor is 255. Quotient is 3. Remainder is 102. In the second division, the dividend is 255. Divisor is 102. Quotient is 2. Remainder is 51. In the third division, dividend is 102. Divisor is 51. Quotient is 2. Remainder is 0. So here where you can get the remainder 0? At the divisor 51. So therefore H.c.f of 867 and 255 is 51. Next, if the H.c.f of 65 and 117 can be written as 65m minus 117, find the value of m. So here they given that the H.c.f of these two numbers is this one. Actually, we know that H.c.f of 65 and 177 by using division method you can get the H.c.f. Here 117 divided by 65. 65 2 ja 130, but here the number is 117. So 65 1 ja 65. 2 here 5. Okay, 52 divide 65. How many times? 1 time 52. That is 13. This 13 again divide the 52. Here 4 ja 52. The remainder is 0. Okay, so where you can get the remainder 0? At the divisor 13. So here by using Euclid division lemma, or division algorithm, here A is equal B into Q plus R. The R is 0 less than or less than B. So here 117 is equal 65 into 1 plus 52. Next 65 is equal 52 into 1 plus 13. Next 52 is equal 13 into 4 plus 0. Where you can get the remainder 0? At the divisor 13. So H.c.f of 65 and 117 is how much? 13. But in the problem they given that the H.c.f of 65 and 117 is how much? 65m minus 117. They are asking that find the value of m. So that is 65m minus 117 is equal 13. Plus 117 is going to right side open. Minus is going to right side open plus. So 65m is equal 13 plus 117. 65m is equal 130. So 65m, 65 into m. 65 multiple is going to right side open, divide. So m is equal 130 by 65. 65 1 ja, 65 2 ja. That is the m value is how much? 2. Next, example 4. Show that every positive even integer is in the form of 2m and every odd positive integer is in the form of 2m plus 1, where m is positive integer. See, even integer means what? It is multiples of 2. Odd positive integer means what? It is divided by 2. The remainder is 1. Okay, so that means the positive integer is divided by 2. We can get the remainder is 0. That positive integer is called even. We can get the remainder is 1. That is called odd. Okay, so here let us take A is any positive integer. Here what asking that every positive even integer is in the form of 2m. That means the integer is divided by which number? 2. That means here what is the divisor here? 2. That means b is equal to how much? 2. So by using Euclid division lemma. So what is the Euclid division lemma? Dividend is equal divisor into quotient plus remainder. A is equal B into Q plus R. The condition of R is 0 less than or equal or less than B. Here the B is how much? 2. A is equal 2 into Q plus R. Here 0 less than or equal or less than 2. So the remainder is what? Greater than or equal 0 and less than the 2. Okay, that means what is the values of remainder here? 0, 1, 0, 1. Here, take that case 1. How many values are getting remainder? 2. What are there? 0, 1. By using this condition, what the condition? It is greater than or equal 0 and less than the 2. 2 is the what here? Divisor. So that is case 1. Here, if R is equal 0, then A is equal 2 into Q plus 0. So 0 is adding to anything, they get the same. So therefore, A we can write as 2Q. 2Q. Q is the what? One positive integer. So here A is multiples of 2. So we can write as A, we can write as 2M. So multiples of 2 is nothing but even number. So therefore, A is an even positive integer. Positive integer. For remainder 0. Okay, next case 2. If R is equal to 1, then A is equal 2 into Q plus 1. So that means that A is here multiples of 2 plus 1. So multiples is nothing but divisible. That means the integer is divided by 2. the remainder is 1. So a number which is divided by 2, the remainder is 1. That number is called what? Odd positive integer. So therefore here we can write as 2 into m plus 1. M is one positive integer. Therefore a is odd positive integer. So here we can show that the integer is in the form of even integer and odd integer. In the cases, if remainder is equal to 0 and remainder is equal to 1. Next, prove that n square plus n is divisible by 2 for any positive integer n. Okay, here say by using Euclid division lemma. By using Euclid division lemma. So here by using Euclid division lemma. Let us take, not only you take that a, you take that n. So n is equal b into q plus r. So here n is equal, what they are asking that is divisible by 2. That means here the divisor is how much? 2. So that is here 2 into q plus r. Okay, so here what is the condition? 0 less than or equal less than 2. So that is here r value is 0, 1. If r is equal 0, then n is equal 2 into q plus 0. It is equal, n is equal to q. Okay, what asking that prove that n square plus n is divisible by n for any positive integer. Here n is given that n is a one positive integer. The positive integer is divisible by 2. That is here n is equal 2 into q plus r. Okay, for first case r is equal 0. That is n is equal 2q. So check here n square plus n. It is divisible by 2 or not. So what the n value? 2q. 2q whole square plus 2q. Okay, 2q whole square. That means here 2q whole square means it is multiple how many times? 2 times. Okay, we can take that 2q is outside. What the remaining? 2q plus 1. So divisible is nothing but multiple. Here the n square plus n, it is multiples of 2. 2q means 2 into q of 2q plus 1. So that is here it is multiples of 2. Okay, so here n square plus n is divisible by 2. Multiples is nothing but divisible. So next, case 2. Case 2. Here, if r is equal to 1, then n is equal 2q plus 1. So here, what asking that n square plus n is divisible by 2. Here, what is the n value? 2q plus 1. That is here 2q plus 1. You can simply we can write as n square plus n means we can write as n of n plus 1. N of n plus 1. So that is we can write as 2q plus 1 of 2q plus 1 plus 1. So 1 plus 1, 2. That is 2q plus 1 of 2q plus 2. In this 2, what the common? 2. 2q plus 2. That is 2 into q plus 2. 2 into 1. So 2 is taking outside. What the remaining? 2 of 2q plus 1 of q plus 1. So therefore here n square plus n here in the form of multiples of 2. So multiples of 2 is nothing but divisible by 2. So therefore n square plus n is divisible by 2.